Have you ever wondered how humans can look at a brand new scene, like a tiny electric seat or a melted apple, and instantly grasp its meaning? That's compositional understanding, the ability to combine simple concepts into something entirely new. But here's the question. Do AI models like those powering your favorite apps possess this same skill? And if not, why? Let's explore a groundbreaking study that's reshaping how we think about AI learning. Researchers asked a critical question. Does scaling up data and model size alone improve compositional generalization? Their answer: not quite. The team analyzed massive datasets like LAIO and 400M, which contains millions of images. But here's the problem: these datasets are sparse. Imagine a cookbook where most recipes lack key ingredients. For instance, tiny seat or melted apple are nearly absent. This sparsity forces models to memorize common patterns, rather than learn how concepts actually interrelate. To test this, they designed controlled experiments with smaller, curated datasets. Think of it as a lab where scientists tweak variables like data diversity and combinatorial coverage. Their key finding: data diversity trumps sheer scale. Adding more data doesn't help if it's not varied. But when they expanded the range of concepts, like introducing more adjectives or object types, the models began to see patterns. They learned to decompose complex ideas into additive components, like how tiny plus electric plus seat becomes a new concept. The study identified 3 stages of learning. 1. Spurious features. The model latches onto surface-level clues. 2. Complex but nonlinear patterns. It starts recognizing rules but lacks flexibility. 3. Linearly factored representations. Finally, the model breaks concepts into clean, additive parts, like a mathematical equation. Here's the breakthrough. When representations are linearly factored, models can generalize perfectly from just 2 examples per concept. It's like learning chess rules from a single game and applying them to any board. But even state-of-the-art models like DINO and CLIP aren't perfect. They show some compositional ability, but not the full picture. The researchers argue that current AI still relies too much on memorization, not structure. So what's next? The study urges us to prioritize representational structure, the rules that let models truly understand how ideas combine. After all, if we want AI to think like humans, it must master composition. Next time you see an AI generate a wild new image or describe a scene, remember, it's not just about how much data it has, but how well it can mix and match the pieces. And that's a challenge worth solving. Ever wonder how AI learns to understand the world, not just memorize facts? Let's break down a study that reveals how models learn to combine ideas, like a kid building with Lego blocks, but with math. Imagine teaching a robot to recognize objects. You show it red circles, blue squares, and green triangles, but what happens when it sees a red square? Can it deduce it's just red plus square? That's compositional generalization, the challenge of teaching AI to handle novel combinations. Here's how researchers cracked the code. They created a simple world, a grid of shapes and colors. Each cell was a unique combo, like red circles, blue squares, etc. The AI was trained on some, but had to guess the rest. But here's the trick: they balanced the data. Every color and shape appeared equally often, like a chef using the same amount of salt, pepper, and herbs in a recipe. What did they find? When data was balanced, the AI excelled at guessing new combos. But if one concept, say red, was overused, the model stumbled. It's like learning to cook with only tomatoes. You can make a great sauce, but a salad. Not so much. The math behind this is profound. Balanced data allows AI to factor out individual concepts, like separating color from shape in its calculations. This is called linear factorization, the AI equivalent of understanding a red square as red plus square. But here's the catch: this only works if the data is fully representative. Miss even one combo, and the system fails. So what does this mean for AI? It's a game changer. More data isn't always better. How you train the model matters. For AI to think flexibly, it needs diverse, balanced examples. As researchers refine these techniques, we're one step closer to machines that can reason, imagine, and adapt like humans. Next time you see an AI generate a wild image or solve a puzzle, remember, it's not just about quantity. It's about the smart, structured way we teach it to see the world. Thanks for watching. Stay curious. P.S. Think of it like learning a language. If you only hear hello and goodbye, you'll struggle to form new sentences. But with varied phrases, you start to get the rules. That's what this research is all about, giving AI the tools to play the language of ideas. Until next time, keep exploring,